Hello there. Welcome to the live lesson recording for dilations. I'm Mrs. Fernandez, one of the pre-algebra teachers here at FLVS. While you're listening to this recording and watching it, I would love for you to please have a calculator, pencil, and paper. Please take notes. You can also probably pause this recording as it's progressing to, if you need to take a moment to write something down or think a little bit of it about the problem that we're talking about. So that would be great. And our objectives for today are, in this lesson, you will understand that dilations preserve similarity, not congruency, learn to dilate a figure, find a scale factor, and connect dilations to the real world. All right, so we have some math vocabulary involved in this lesson today. So be a lookout for and listen for these words: dilation, reduction, scale factor, image, enlargement, similarity, and pre-image. Okay, so let's start thinking about dilations. What do you already know about dilations? Do you have any knowledge about dilations prior to coming to this live lesson? Take a moment and think about what you already might know about dilations. Okay, so let's talk about those dilations. So dilations are a type of transformation that is different from the ones that you've learned so far. When dilated, there is a change in the, but not the shape of a figure. What do you think might go in this blank? If you thought it was the size, that is right. The size does change when you have a dilation. Okay, so now we're going to have another fill in the blank. Dilations are not rigid transformations because the side lengths of the figure become what or what? What do you think goes here? They become larger or smaller. Okay, so with dilations, the side lengths become larger or smaller. Okay, so that's why the size changes, because the side lengths get larger or smaller. Okay, I've got one more fact about dilations. Okay, dilations result in blank figures, which means their angles are congruent and their corresponding side lengths are proportional. Okay, so what type of figures are those? Okay. If you were thinking similar, that is correct. Yes, dilations result in similar figures because similar figures have angles that are congruent, but the corresponding side lengths are proportional. Okay, if you want to write that down, please do pause this recording to do that. If not, I am going to continue. Okay, here's something I do want you to think about throughout this lesson. We're going to start talking about scale factors, okay? That's one, something that was on that math vocabulary board in the beginning. So we're going to be now from here on to the end, we'll probably be using scale factors on every page of this live lesson. But while we're working through it, this is something I want you to keep in mind. How are scale factors used in the real world? Okay, if you have an idea about how they're used in the real world as we're working through, write it down on your paper. So, normally we'd be sharing that at the end, but please make a note of that. of any ideas that you can think of how scale factors are used in the real world. All right. But first of all, we need to talk about what is a scale factor, right? Okay, so here is the definition of that. Scale factor is a ratio of two corresponding lengths that determines the change in size from a pre-image to an image. So let's make some sense of that. And we've got some good vocab words coming here. All right, so let's look around. Let's take a look. I'm just going to do I'm going to cover this up just to, so we can just do one side at a time. All right, so here I have an example of an enlargement. Okay, notice that I have two triangles. Okay, we have a triangle here, and then we have this second triangle. Okay, so since it says pre-image, this is the triangle that you're starting with. Okay, and then after the dilation, it becomes the image, okay? So it goes from pre-image to image, all right? And notice how this orange triangle became larger. It got bigger, okay? So that's a dilation. Its size increased. The side lengths got larger. Now, and it had a scale factor of 2. So when you see a scale factor that is greater than 1, it represents a dilation that increases the size of the pre-image, okay? So since the scale factor is 2, it's like this triangle doubled, okay? So it got bigger. That is an enlargement. So when you have a figure that, has an enlargement, that means that it has a scale factor that is greater than 1. It's like in this case, it's 2, okay? And just remember, pre-image is first and then comes the image. And then something else to note, notice how this is A and this is A with this symbol here. That's, we say that as prime, okay? This is A prime, okay? A prime means, that little tick mark there means that a change has happened. So A is first and then the A prime, okay? Let's look over here and do the other one. We're going to talk about a reduction. Okay, so once again, we have a pre-image and an image. Our shape here got smaller. That is right, it is a reduction. Notice again, we started with the shape Z, and then we ended up with Z prime. Okay, that's the second shape. And if it got smaller, your scale factor will be less than 1. And yes, the scale factor in this situation is a half, because the new shape is half as large as this one, okay? And we're going to do more scale factors, but this is just an introduction. Pause this lesson if you want to write something down. Okay, so what do we have here? We are now going to dilate a figure using a scale factor. Okay, so we're going to find the new side lengths using scale factors. Okay, so, I just do like to just cover this up a little bit just to make it, just so we can look at one thing at a time, but I am trying to do that. Give me just a moment. There we go, just to make it a little less distracting. Okay, so we got 2 green triangles over here on the left. Okay, let's go over there. Okay, so the scale factor is a half. Okay, so we're starting with A and then we're going to A prime. So how do you find the new side lengths giving the scale factor? Well, the trick is multiply. You multiply with that scale factor. So that is how you do it. So you're going to take each side and multiply it by the scale factor. So what you're doing is 6 times, okay, 1/2. Okay, so you can use your calculator for that. You can do 6 times 1/2. You can do 6 times 0.5 if that's easier for you, or think half of 6, which is 3. Okay, so each side, 6 times 1/2 is 3. Of course, on all sides, because we have all 6s on that left triangle. Now we're going to have all 3s here. So you're going to multiply with that triangle. multiply with that scale factor, excuse me. And that makes sense to me because I'm looking here and I realize, yes, this scale factor is a half. My triangle should be getting smaller, and it sure did. Okay, great. Let's try this next one. Okay, scale factor of a 3. All right, so we're going to do the same thing. You're multiplying with the scale factor. So all my, this is a square here on C. So all my sides are 3, which is nice. So I'm just going to multiply 3 times 3. And I am going to get 9. So that is my new side lengths. Boom, boom, boom. All right. Okay. All right, so that's not too bad. Next up is we have a graph. And no problem, you guys got this, okay? All right, so let's read this. Let me see what this says. Determine the vertices of triangle F prime, L prime, A prime after triangle FLA is dilated with a scale factor of 2. Okay, so here is my triangle FLA, okay? And I'm going to dilate that with a scale factor of 2. Okay, so all you have to do on this, we're going to determine the new vertices. So that means you're looking for the new points here, okay, like these orange points, okay, for the new larger triangle, right? It's going to be bigger because we're going to be doubling it. So the first step for you to do is find the points for FLA. Okay, so I did already provide them down here. So let's just review those. So for F, there it is. You always do X first. So that's the -3. And then you do the Y second. That's -2. Okay, so -3, -2. And then you'd same thing with L and A. So basically, since you are dialing this scale factor 2, you're doing the same thing. You are multiplying each of those with 2. Okay. Now, if you do have a little trouble with, negative numbers, then you definitely will want to use a calculator for this. Okay. So you would start off by doing -3 times 2, which is -6. And then you'll do the -2 times 2, which is -4. Yes, okay. So why don't you pause this recording, and then I want you at home to try to do these yourself, okay? Find out the coordinates for these. So go ahead and pause that, and then replay when you've got those, and you can check your answer. Okay, so the correct answers for those are -6, -2, and -4. Nope, it's -4, -4. Yes, okay. Take a look to see how you did. Now, it didn't say to graph these, so we don't have to graph them. It just says find the new vertices. So that's what we did. There they are. And something I want to mention is in pre-algebra in our course, we are only doing dilations centered about the origin. Just like when you did your rotations earlier in that other lesson, these are also only about the origin, okay? And maybe in further, more advanced math classes later, you will do different types of dilations, but that's all the kind that we're doing in this course. Okay, so if you need to take a moment more with this page, pause it, think about it, but I am going to keep going. So come with me to the next one. Great, so let's see what we have here. Okay, so we are going to learn to find the scale factor of a dilated figure. So now we're going backwards. Now the figure's already dilated and we need to find out what the scale factor is. So here are the instructions on how to do that. To find the scale factor, choose 2 corresponding sides, set up a ratio with the image measurement in the numerator and the pre-image measurement in the denominator. Okay, so basically here's this great formula, which you should be writing this at home for sure. So the scale factor is going to be a ratio of the image over the pre-image. Okay, so write that. And let's practice. Okay, so all right, so what I'm going to do, and I suggest this is a great way to start this out, is I'm just going to make a note here. Okay, image over pre-image. Okay, so my image is my R prime. And then my pre-image is just my R. So I'm just going to write this here just so I don't get things mixed up. And I think it's a great thing for you to do too. Okay, so now after this, we are going to find corresponding sides to put in the ratio. Okay, so I'm starting over here. Well, I can pick any side. And you know what, honestly, like I'm not going to pick this. This is kind of a tricky number here. I can pick 5, totally going to pick 5. So I'm going to pick 5. And so when your figure doesn't have like vertices labeled here on the end, you just look at visually what corresponds. So this side, this 5 is going to correspond with this side. Okay, so I'm going to put 5 on top and 10 on the bottom. Okay, and then I'm going to simplify 1/2. So my scale factor is 1/2. Okay, if you want to check it, then you could always multiply it out just to see. For example, we're starting with this triangle first. 10 times 1/2 is 5, yeah. 14.14 times 1/2 or divided by 2 or times 0.5, it equals that. So you did it correct. Okay. All right, let's do this one. Okay. All right, so now here we are with a coordinate grid. So we have, and this is like different, written a little differently. You have points here on the ends, that's fine. So we are just going to do corresponding side, in the, excuse me, in the definition it says corresponding sides, but here with these graphs, you can do corresponding vertices. Okay, so let's just focus on A and A prime. So here's my A. Here's my A prime. So remember the image goes on top. So I like before, let's practice that. Let's do A prime on top, just so we don't get things mixed up in the wrong order, okay? And then A on the bottom, image over pre-image. Great. Now, all right, so let's identify these points. Okay, A prime is going to be, we can do X first, right? 3, 6. Okay, and then you at home think about what the coordinate for A is. All right, if you said 1, 4, you are correct. No, 1, 2. I went to the line up here. Sorry. Okay, let me just make sure that's right since I made a little mistake the first time I tried it. There's A right there. Let me just double check. X is 1. Okay, 2. Yep, 1, 2. Very good. Okay, now, all right, so now we're going to, set up a ratio. All right, so you're thinking, well, what number am I going to pick? We have 2 numbers for A prime. You know what? Either one. Doesn't matter. I'm just going to pick the X, the 3. You could do the 6. That's fine. So if you pick the 3 for X, then you need to do the 1 for the A, okay? Here's your, so if you're choosing X's, you got to stick with it. 3 over 1. And 3 over 1 does simplify to be 3. Okay, and then if you notice, if you did 6 over 2, it also would have been 3, so it would have been fine. Okay, so we found 2 scale factors. Now, let's look at this. How do you know if the scale factor you found makes sense? Think about that. All right, so hopefully you were thinking that you're going to go back and just check to see if your shape was an enlargement or reduction. So those, oh, I'm using those vocabulary words that we were talking about before. So for example, this was a reduction. And so if it's a reduction, it should be a fraction less than 1. 1/2 is less than 1. Looks good. Okay, so we went from this triangle to this one. It got bigger, enlargement. So that should be a scale factor greater than 1. It's 3. And by the way, let me just say this with you guys right now. You know, I've been talking about if scale factors are less than 1, scale factors are greater than 1. What would happen if your scale factor was just 1? What do you think? What would that mean? Okay, if you're not sure, okay, so maybe you don't know, you're still thinking. Well, if you multiply something by 1, what is the result? Your number stays the same, right? 5 times 1 is 5. 10 times 1 is 10. So that would mean it wouldn't be a dilation. It would stay the same. Okay? So a scale factor of 1 really doesn't exist because that would not be a dilation. It just stays the same size. All right? That's what happens if it was 1. Okay. Let's go pause real quick right now if you need more time here, but if not, we're going to keep going and we're going to practice this some more. Okay, so I want you to try this on your own at home. Go ahead and press pause right now. I want you to try both of these. And then come back and press play when you have, your answer tried both of these, okay? Okay, welcome back. I hope you tried these at your home and let's practice. Okay, let's start. Once again, I just need this and I think it's a good idea. Please go ahead and write your ratio formula. So I'm going to do A prime over A. Okay, and then I'm going to pick course a side. I'm going to look at my numbers that I like. Let's see, what am I going to pick? I don't know, 10. 10's nice. Okay, I'm going to do 10. So 10 on top, and that corresponds to what side? To the 15. Oh, they actually color-coded this too to help us, so that's nice. Okay, so there's your scale factor, 10 over 15, but you want to simplify. So common factor is 5. So divide out 5 and you're going to be left with 2/3. Okay. And just to show you, if you did it another way, maybe you did 4 over 6. You chose those sides on the top there, it still would be 2/3. Okay. Okay, and now let's go over to this dilation over here. Let's just take a look what's happening. Starting with this one, then it goes to this one. So it is a reduction. I'm going to, you know what, I'm just going to go with those K's. So K prime over K. And I just liked those X's. So I'm going to work with the X coordinates on that. So this one, oh, I got to do K prime first. This one goes to 1. So 1 on top. And then this one corresponds with 4. 4 on the bottom. Oh, and perfect. I didn't even have to reduce this one. So actually that was a good pick. 1/4. Okay, and let's just check to see if these scale factors make sense. Okay, let's see. We started with this, what started here, excuse me, and went here. So that was a reduction. Yes, fractions, love it. And then we started here to this one, again, a reduction. Yep, expected. And hey, so good. I hope you're understanding this better. Hopefully you made some good progress on trying these at home, and just also wondering, have you been thinking about how scale factors are used in the real world? So try to think about that as you go. Jot a note down about, where you think that could be used. Okay. So looks like we are going to try 2 more. Okay, we got lots of practice today. So once again, pause right here, try these yourself, and then come back. All right, so hopefully you tried these at your home, and I hope you did your best effort. If it's okay if you're having trouble with this, but you do need to try, okay? So please keep trying. All right, so I like to just focus on those A's. Just let's make this as easy as possible. So I'm going to look at, this point here and this one here. Triangle ABC with those vertices is dilated to create triangle with vertices at these here. Okay, so once again, I'm just going to go with A prime just because it's easy. It's in front. Why not? But of course, you could always do B prime or C prime. Okay, so there we go. There's my little formula to keep me on track. And why not just be consistent? I'm going to pick the X again, but I need to go to A prime. See how easy it is for me just to make that little error of going up here, going to the one first. This is what's keeping me in check. Okay. I mean, I don't know why. I just naturally want to go to the one that's first here, A first, but that's not right. I'm so glad I wrote this down to keep me from making that mistake. Okay. So please, why don't you guys do the same thing? Okay. So A prime, I'm going to choose the X. I'm going to go with the 6 over 2. Okay. So where did I get that from? 6 is here, the X coordinate part, and here's the 2. X is 2 there. And then simplify. 6 divided by 2 is 3. Scale factor is 3. So, we don't have a visual to know if this got bigger, but you could always graph it at home to see if it was an enlargement or reduction to check this. Or you can just kind of think about it and think, well, this started as 2, 1. These got bigger. These got bigger. These got bigger. So yes, the scale factor was a number that made it increase. So that would be 3 would be definitely a possibility. Okay. Okay, so I'm going to write why not I'm just going to keep the A's going. You don't have to, but it's comfortable, it's easy. And I'm definitely writing this down to keep me in line. Hopefully you are doing this too. Like, you were supposed to try these problems before I started working them. So I hope that you did the same. And you learn more from this lesson if you are trying these out instead of just totally listening to me talk you through. Okay. All right. So A prime. Well, interesting. How am I going to do this? So actually, I am thinking of lengths this time. So it's written a little different, and that's okay. So I'm actually going to think about doing, why don't I rewrite it like this? AB prime. Oops, there we go. And then just AB, okay? The writing is not spectacular. Sorry about that. There we go. AB. You know what? I'm going to rewrite that because I just think that's bad. Let's make that look a little better. Okay, so I'm going to do this side that goes from A prime to B prime. There we go. Okay, that's a little better. A little better. Okay, so let's take a look. So the sides that I'm going to be working with are here, these right here, and this one, because they are the corresponding sides. They connect A and B, okay? So the primes are on top. The image is on top, so that's going to be 20. And the pre-image is going to be below it, and that's going to be 12. Okay, now, so 12 does not go into 20 evenly, so this is a fraction that I am going to have to reduce. Thinking of a common factor is 4. So I'm going to factor out the 4, simplify this, so 20 divided by 4 is 5. 12 divided by 4 is 3. So my scale factor is a fraction. Okay. But this fraction is greater than 1. Okay, 5/3 is greater than 1 because if you recall, 3/3, which I'm writing down here at the bottom, so 3/3 is equal to 1. Okay, so if you have 5/3, that's greater than that. So that is why this is an enlargement, which it is, because this triangle enlarged to this one. And 12 times 5/3 is 20. And then same thing here, 9 times 5/3 is 15. So even though this is a fraction, it's still an enlargement because the numerator is greater than the denominator. So this could be something that you might be alarmed thinking, oh, this might not be right, but it's okay, it is. You know, not all fractions are less than 1. Okay? Actually, there's probably more, there's definitely more fractions that are greater than 1. Okay? So there you go. Pause this if you want. But I am going to move forward, so come with me if you're ready. Okay, so here we are at that question. Did you think of anything? Did you think of any ways scale factors could be used in the real world? What did you think about? What did you write down? Or what are you thinking about right now? Take a moment. Okay, so I'm going to tell you some things. So often scale factors are used in construction. You know, architects use them, engineers. It's pretty much when an object is too small or too large to be drawn or constructed at actual size that they use scale factors for scale drawings. Okay, so that is how scale factors can be used in the real world. There could be more options than that, but that is something that that is definitely possible. All right. Okay. And here is a video of someone using the scale factor in the real world. Now, this was a kind of a long video that I did clip, so it does have a little, it is a little, you can tell it breaks in the middle, so I just thought we'd want a shorter video. So please listen to this. Let me get it set up so the sound will come on. I'm hoping it will. Okay, so here we go. So take a moment to listen to this, trying to find how to play it. Okay, having a moment here. Let me try one more little thing. Hopefully this will enable the player. Oh, there it is. Whew, close. That made me nervous. Okay, here it comes.
You know, scale factors aren't just used in the classroom. They're used every day by people like architects, engineers, scientists, and even artists. But today, I'm going to use scale factors right here in my own backyard. I'm going to build a new workshop because the old one, well, I just don't think it's going to cut it anymore. Let's see how they can help us out. Now, I can't just start building at random and hope it all comes together. Instead, I need a plan. So I've used a simple drawing program on my computer to create a set of plans, one for the floor plan and one for the walls and trusses, the triangular structures that support the roof. But what the plan represents is simply a scaled-down version of what the actual building will look like. The building will be scaled up by a factor of 48 from the plan. In other words, 1 inch on the plan represents 48 inches on the building. So as I work, I just measure directly from the plan and multiply by 48 to get the actual size I need to cut. Okay, now I've used scale factors to help me build my foundation and the floor. I've built it according to my plan, followed the proportions that were here. It's 16 feet wide and 32 feet long, which means it's twice as long as it is wide, just like on my plan I made. Now I'm going to see how I can use scale factors to help me build the walls. Well, I started with a good plan, and that plan is becoming a reality, thanks to the fact that I'm able to follow my scaled drawing. Everything on the real building is proportional to what I have here. All the angles are congruent. All the triangles are similar. Everything is just as it should be, thanks to using this principle. I still have a long way to go, but I know my building's going to turn out just the way I planned it.
Okay, so I hope that that video worked out for you. Just do some adjusting here real quick. Okay, so as you can see, this man, he, was making, constructing his shed there. And so he made a drawing and then used a scale factor for the actual size. So there you go. That is an example of how to use scale factors in the real world. Hope you found that interesting. Okay. All right. And that concludes our recorded lesson today. I am so glad that you joined me. I hope you learned a lot. Let me just go over a couple things real quick before you leave. Let me get this. Okay, so if you still need some more support, you can also visit the Dilations Toolbox for additional notes and videos. So go to your math page, go to course resources, and look for clicking here. It'll open up, if you're in pre-algebra, it's going to be 605. If you're in advanced 7th grade math, I'm not really sure what lesson it is, but you should know which ones the dilations are. So you look for that, or potentially sometimes there will be buttons here to click too. Okay. All right. Well, you all, thanks for coming. Make today awesome. And I hope this was helpful. Thanks. Bye.